Hi guys, it's Mr. Johnson. Today my goal is to show you how to draw an atom. Now this is one of the Gen Chem skills that we don't have a whole lot of time to practice in AP Chem, so that's why it's homework for you. Okay. Once you get the hang of it, it'll take you no time at all to finish this homework. So without further ado, let's go ahead and review what we know about the atom. Now last year, your wonderful physics teachers taught you, and you should know, the three different subatomic particles, which are, pop quiz, protons, neutrons, and electrons. Now, your protons, if you remember, are heavy, and they are in the nucleus. Same with my neutrons. They're heavy and in the nucleus. The only difference between them is the charge. Okay, the electrons are different, though. They are really light, and they are in last year we said outside the nucleus. This year we're going to say they're in shells. Okay, so heavy nucleus, electrons light in the shells. Electrons are like the flies buzzing around the elephant's butt, and he's trying to swat them off with his tail, but they're just so fat they just kind of buzz around, do their own thing. Except if you took that entire elephant and shrunk him down to a really tiny little size. Okay, like the size of a pinhead or a pen head. That would be more appropriate of a picture in your head. Okay, but moving along, protons are positive, if you remember. Neutrons are neutral, if you remember that. The way to remember that, P, positive, protons. And neutrons, you got to remember the whole first part, neutral. Okay. Now, electrons are negative. Okay. So that gets us caught up to what we should know from last year. Now, how do we take that and apply it to these different models of the atom? Go on to draw a ring model diagram of the atom. Okay, so and really the idea is here behind this is not that they're going to ask you to do this on the AP exam. The idea is, do you have enough practice reading the periodic table so that you can tell what the protons and neutrons and the electrons are from looking at a given atom? So that's the first step, is actually to look at the periodic table and find your box for your elements. Okay, let's say we're working with lithium, and they're oftentimes arranged differently. I even showed you guys the circular model in class. If I didn't, ask me tomorrow. But a lot of times they'll put the first number up here, okay, and the second number over here. And the second number usually has like 25 digits after, like 7.432, blah, 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 blah. We're going to, for this lesson, chop off all the extra stuff, which is slightly important but not important for drawing, and we're going to call it just a round number. Okay, so this here is called Z, which is called the atomic number. That's like the ID number for this different atom. So lithium's ID is number 3. It's got 3 protons in its nucleus. Okay, if you change that number, you're going to a different atom. Just like if I changed a lunch number, I'd be like saying I was a different student. Okay, I'm in pasta. Now, this number is called A. That is the atomic mass. And of course, remember, where's all of our mass? It's in the nucleus. So that's the number of protons plus neutrons. Okay, that's going to be important in a second. Now, next step is to go ahead and calculate number of protons, neutrons, and electrons. Protons and electrons are easy. Neutrons are also easy, but they take an extra step. Okay, so I mean, really, once you get the hang of this, you guys will have no problem. So protons, well, it's equal to the number of Z, because remember, we already said that's the number of protons. That's by definition, atomic number is the number of protons. That's 3. Okay. For now, the number of electrons is also going to be equal to Z. And I'm going to put that in quotation marks because it can change when we get ions, but we'll talk about those next unit. Okay. So for right now, it's going to be equal to 3 as well. Okay. Now you might be thinking, "Oh, I've got a pattern. It's all 3." And for the first couple elements, you're right. Okay, but don't let that trick you to think that's always the case. Different atoms, especially as you go bigger, they need more neutrons in there to balance out all the positive charge. Because remember, protons are all positive. So if you have all that positive charge bunched up in the nucleus, it makes it more unstable. So they need more neutrons to sort of even it out. Okay, and nuclear chemists have models for this. That's actually how we discovered a lot of the transuranic elements and all these other guys, the lanthanides, actinides. But if you're interested in that, I would really encourage you to go home and watch a video called Island of Stability. It's on YouTube. It's by Nova. It's very interesting. Okay, it's about how we discovered how we make new elements. So number of neutrons, how do we figure it out? Well, remember we said that neutrons are massive, so are protons. Okay, so this mass number, atomic mass, is equal to protons plus neutrons. If I subtract out the number of protons, say by doing A minus Z, then I will be left with the number of neutrons. Okay, a little bit of arithmetic for you guys that passed fourth grade math, and there you go. Actually, that's probably first grade math, like 7 minus 3. But there's 4. Okay, so now we're on the last step. All we have to do is take what we've done and draw it. So we need to start out by drawing in our nucleus. Okay, that's easy. 3p plus 4n0. And I usually just like to make it squiggly. That way I know that it's not just another shell, okay? Because after that, you draw shells around it. And if you don't separate it, usually what I have students do is they try to put another X there or put my electrons on that first circle. Well, that first circle is not a shell, it's a nucleus. Okay, so you lose points for that. That's not good. It just shows that you understand this model, that you know what's going on. Okay, so don't put your electrons there. Put them on the outside. Now, let me get a nice pretty color here. How about a nice little orange or mauve or whatever that is? I don't know colors. Okay, so last thing we need to do is fill in our electrons. Now we follow what we call the 2-8-8 rule. Okay, and electrons always like to be as close to the nucleus as possible. And a lot of people, when they explain that, they'll say, "Oh, electrons like to be happy, so they like to be close to the nucleus. It's like a love story." Except there's a really angry love story, because if they're far away, then they'll kind of jump around and attack each other and get closer, and it's a strange, terrible world. Okay, it's not a romance novel. It's not Twilight or anything here. Okay. Well, Twilight's kind of anyways. So you put your electrons as close to the nucleus as possible, not because it makes it happy. Really what they mean when they say happy is that it makes the atom lower in energy. Okay. When you get your electrons as close as possible to the nucleus, you're minimizing the Coulombic potential energy, and that's going to make your atom behave nicer. Okay, so you'll always put your electrons as close to there as possible. Well, we can only put 2 on the middle one. It's like you have a Ducati motorcycle going to prom. Of course you want to ride on that, but it only takes 2 people. Okay. After that, you go to the stretch limo. You can have 8 people in there, and you still want to go to prom regardless. So if you need to, you'll pile in with 8 other people into your mom's minivan, but it's not going to be a good time. So you want to fill that first shell first. Okay, we've only got 3 electrons this time, which makes our job easier. Okay, so we start with the middle, fill out. So we can put 1 there. We can put 1 there. Now, that shell is full. It has 2 electrons. Okay, now, but you notice we still have 1 electron left over because we need to have 3 in our model for it to be accurate. So we put it up on the second shell. If we had more, we'd add up to 8 there, and only then would we go out to this last shell, the outside shell. Okay, so, and in a few weeks, what we're going to end up calling these is, let's choose a different color. We'll call this the core electrons now, because they are on an inside filled shell. And we will call this a valence electron. Okay, that'll be important very soon, so I just want to get you introduced to that. Now, valence electrons are the fundamental. They are the foundation. They are the cornerstone for all bonding. Okay, so it's going to be very important that you know the difference between those two. Probably next year. Okay, just give you a heads up with that. So go ahead and practice this on your homework. It is due on Friday. Make sure that while you're going through it, if you have any questions, let me know. Okay, don't wait until Thursday night to start it, because then you'll never get your question answered. Okay, so I hope you guys do fine with this. Good luck. Let me know if you have questions.